Alright, today we are solving the problem 1352 product of the last k numbers, and you have to design an algorithm that accepts a stream of integers and retrieves the product of last k integers of the stream. So if you read this problem, it basically says that you have to maintain a list or some data structure where you add the numbers, and then you're given an integer k, and you have to pop last k elements and return their product. So the brute force solution is obviously O of n time, but that doesn't work. That gives you DLE. So we can optimize it to be almost O of one solution. So um, so the idea here is that it is similar to prefix sum, where you do some pre-processing, right? So in this case, you uh, as you encounter new numbers, you keep adding them in your product array. And the only caveat here is that if you encounter a zero, then it's gonna mess up all the products, right? So you need to keep a track of the indices where you encounter a zero, and uh, then you know when you are asked to get the product of like last k elements, you can just check if the if the in if like if any of the indices in the last k elements are a part of the zero indices array, like the last element of zero indices array, and if it is, then you just return zero because the product is anyway going to be zero. If not, you can calculate the product in using your product array and then return it. So there are a lot of cases, like a lot of conditions in this problem, so I'm not gonna explain all of them in detail, but you can get an idea from the code. So let's maintain a self dot product, and let's maintain self dot uh, indices. So we can call it zero index, right? And um, so first is the add function. So first of all, uh, if you have no elements in the product and zero indexed, so if length of self dot prod is zero, you just append to it self dot prod dot append num, and you check if the number is equal to zero. If it is, you add it to the zero index array. Index dot append, so it's the first element, so we're gonna append index 0 to it. If not, there are two cases that you should check. The first one is if number is number is not equal to 0, and if the number is not 0, you have to, so for this example, let's take the first example. Here, if the number is not 0, like you have to, you can take the number and its previous number, but you have to check if the previous number is not equal to 0, otherwise the current product is going to be 0. So for that, you can check it like if self dot product of -1 is not equal to 0, or there's another case called length of self dot 0 index is greater than 0. If this is the case, you can append the current num times the previous product, and if not, you can just append the current num. So just like this example, after 0 you have a 2, right? So for that you just need to append 2, And for the next case, you can append 5 times 2. So this is if the number is not equal to 0. If it is equal to 0, we just append that number. I mean, we just add it to the prod. So append num, and we have to add it to our 0 index array. So here the index is gonna be uh, len of self.prod minus 1. So I believe this is the entire add function. Now let's get to the get product function. So in this case, you still have a lot of conditions here. So first of all, let's check if we don't have any 0 indices, right? So if length of self dot 0 index is equal to 0. So if we don't have, then we can just return, sorry, we can return self dot prod of -1 and divide it by the product. The last element is going to include all the elements, the product of all the elements, but you just need k, right? So you have to divide by the remaining elements that are not part of the k product. So that is self dot prod, and then we pass the length of self dot prod minus k minus 1. So you can try it out, try run it. So it's gonna be the same. And here we have a case that if k is equal to the length of product, then we just return the last element. Otherwise it's gonna throw an error, because this is gonna be the same as the last element, so it's gonna mess up your answer. And if we have some 0 indices, so we just need to get the last index. So last index is self dot 0 index and -1. And here we check that sorry, if length of self dot prod minus k is less than equal to last index. If it is, we just return 0. If not, I'm just gonna paste a line of code here. If not, we do this. So we check, we get the denominator same as the previous one, and if it is 0, we just make it 1 and just return it. And I believe that should be good. I'm sorry, I'm running low on battery, so I gotta check if there's an error first. Solder Pro minus k minus 1. Seems, oh wait, this is equal to 0, sorry. Yeah, there you go. Right. Should be the most optimal solution. There you go. All right, see you tomorrow.